Streaming's on. Okay, we can start with this notes. As these are the three things, and we're going to go back to ethical, well, we're going to go back to objectivism and subjectivism as again, just to re-emphasize. And yeah, it is actually going. And why don't I put those two down? Can you summarize those while I just quickly do attendance? And schedule. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, hold it. We've got two people away? 1, 2, 3, 4, 5, 6, 7, 9, 10, 12, 13, 14. 14. So, is Matson here? That's who we're missing. Computer should be away. Matson. Okay, review. Meta-ethics. When something is the meta of, it is essentially the study of, or that thing in of itself. So meta-learning is learning about learning or the study of learning itself. Metaphysics originally stood for how do the laws of physics come about, and what is the physics of physics. We've been doing the ethics of ethics. What are the different kinds of ethics, the study of ethics itself. And much of that is spent defining what isn't ethics. Law, personal belief systems, natural law fallacy, and what things use for ethics, but we don't call ethics. So of the ones on the board, only one of these is something that we're going to call ethics, which is ethical objectivism, where you can say you're right, you're wrong. The other ones are ones people use. And ethical relativism just means it's right for me, and while if you did it, it wouldn't be right for you. That's okay because you don't believe in it. So different ethics for different people, and that's extremely tolerant. It's not a form of ethics because it just means everything is an opinion. There's no way to have a right or wrong. Now, if you don't believe their ethics is objective, that's kind of what you're left with. Ethical emotivism, everything is good that you feel is good. Your emotions take the place of the ethics. You may argue over which TV show is best because you like that TV show, and it's also perfectly fine that someone else doesn't because they don't like that TV show. And treating ethics like that, I like this, therefore this grosses me out, therefore it's wrong, are often used in ethics, as we've seen. These fall down a little bit when we get to really difficult ethical decisions or condemning certain practices. If you, for example, believe that infanticide is wrong, if you were an ethical relativist, you'd be like, well, it's wrong for me, but if you want to leave your children out to die from the elements because you don't like their gender, that must be okay for you. And that doesn't seem to be what ethics is. Some of the problems, confusing what is with what should be. Strong belief isn't in and of itself something that makes it right. And so that if someone really, really believes infanticide is correct, it doesn't feel like that should necessarily be true just because of that. Objective ethical systems look for systems that everybody can see that this is how we define good. Now, we do have more than one objective ethical system that does that. And they disagree with each other. But we have that in other areas as well. Quantum physics and relativity also disagree with each other. We haven't sorted out that problem quite yet. So, I've heard the nobody agrees, so there can't be ethical truths. Not everybody has to agree for something to be true. If you've ever been in a math class, that's usually an area where there is an absolute truth at the end of a proof or a question. And not everybody may agree on the answer, but some of those people just might be bad at math. Also, like math, this seems to be a skill. Math is apparently true, but we just pick it because it seems to be useful. We don't do experiments in math. There's no way to fundamentally prove it correct or incorrect. We know at this point that math is actually broken and isn't internally correct even, which I'm sure your math teacher has mentioned a couple of times because it's kind of funny. You haven't? Miss Walensky definitely has. Oh. And Mr. DeSantis, good. Oh, so someone who knows, why is math broken? Why is math broken?
To do with like
sets. Yeah.
The set of all sets does not contain itself.
The set of all sets that do not contain themselves, does it contain itself? and it can't. And the problem with it, it's not just a funny sentence. For those of you who aren't in any of those math classes, a set is just a grouping of things in math. So you can have the set of all even numbers, you can have the set of all odd numbers, you can have sets of sets. So you can have the set of all even numbers and the set of all odd numbers in one set. And so you have a set of numbers that consists of all the sets of numbers that don't contain themselves.
That's never, I don't know. I can't even process that. Like, I don't, yeah.
And one of the difficulties, and this may seem, well, math is broken. By the way, I love did they tell you how math solves this problem? Yeah, you just ignore it. It's called naive set theory. You just wander around pretending the problem doesn't exist. I think that's hilarious. If you cannot internally make math consistent, we program computers with math. So if you're making an artificial intelligence, it would imply, like those classic 50s and 60s computer science movies, science fiction movies, in which robots break down because you give them an insolvable math problem. You have to be able to program, and you have to be able to come up with conditions that are going to work. It implies that the rules we're using to program things have areas in them that just will never actually be able to make sense. And we don't have an answer to this particular problem right now. It actually has an effect on programming and artificial intelligence. So we just made up math because it's convenient. This might be an artifact of the fact that we made it up. We made up the wrong rules. Also, you can make up other rules. There's sets of maths in which two parallel lines cross over each other. And not only cross over each other, but cross over each other an infinite amount of times while still being parallel.
Isn't that just changing the definition of parallel, though?
Yeah, and then you just derive all your math for that. So when we look at things, when we make math, we just look at it and go, parallel lines never touch, and we just accept that. And then we derive math from that. If you take two quantities, both of them positive, and you add them together, you get a bigger quantity. That's just a property. It's called the additive property. You can derive math in which that's not true. Two things, when added together, if they are both positive things, actually end up making the same as the biggest one as a type of math. And some people invent this type of math for fun. And then one day we find an area of the universe that really actually uses that type of math. And it can be useful. But they're all just made up games.
So
yeah.
Shouldn't go to math class because it's broken?
Well, we don't go to math class because it's fixed or broken. Why do you go to math class? Other than the fact that you're forced. Like, the sort of meta reason, why are you forced to go to math class?
Because most people believe in math.
Do they believe in math?
Well, maybe not everybody does, but math's required to get things that we want later in life, and it's believed in by most people.
Yeah. It's why do people believe it?
As far as they know, it isn't wrong.
Well, I just told you it was wrong, and yet you're still learning math, and are you going to use math?
Still applicable even if it is wrong.
Yeah. Lots of things are useful, even if they're, ultimately wrong. I mean, your science teacher probably teaches you things all the time and says, in a year or two, your other science teacher is going to tell you this is wrong. We teach you simple models that work.
The Bohr model.
Yeah. The Bohr model is still brilliant. You can use the Bohr model for multiple areas of chemistry. And if you just tweak it a little bit, you can even use the Bohr model in quantum quite a bit. The quantum model requires math that requires supercomputers to fully chug out shapes and spatial awareness. It's a terrible, terrible practical model. Bohr model works great. Unless you're doing quantum chemistry, you don't need it. You can get from here to the moon using Newtonian physics. You don't need relativity at all. But the only time you need relativity in our solar system is if you're trying to go from here to Mercury, because its orbit would be slightly off. But even then, you could probably course correct. It's not off by that much. Mercury moves just fast enough that its position is just off a hair where it would be predicted, which Newton noticed and was quite annoyed by because he didn't know how his math was wrong. And it turns out he didn't know that things slow down the faster they go. Is that, sorry, one of today's lucky 10,000. Are you aware that things slow down the faster they go? I'm missing a key word in there. Slow down in time the faster they go. So everybody's seen, who hasn't seen Interstellar? Oh. Did lots of people haven't seen it? It's an older movie now. Yeah, we're not going to watch the whole movie now. But they land on a planet. Time goes really slow. Spoilers, by the way. Sorry. Because they're in a deep gravity well. Gravity affects time. Speed affects time. If you are running really, really, really fast, and by really fast, I mean you're getting to sizable percentages of the speed of light. Time for you is slowing down compared to the people who, or everything that's not moving, relative to you, which is why it's called relativity. From your perspective, everybody else is speeding up. So if you went into a spaceship and then just zipped around the Earth at, say, 95% the speed of light for a little while, and then stopped and came back down, you could find you have aged a year, while everybody else on Earth has aged 8,000 years. You have managed to find a way to travel forward in time faster than everybody else. Now, you can't go backwards, but you can affect your rate of going forwards in time. We know this is true because to beam our messages from our cell phones to satellites, we have to account for where they are using relativity, because although it doesn't really happen that really noticeably at slow speeds, it's fast and it happens enough that we have to account for that in their orbits. We also have to account for the signals that are moving back and forth. And so we need relativity for all of those. Eustace, your hand was up.
I saw a video of it, so that if you go like in the really outside part of a black hole and stay there like 1 minute.
Yeah.
On Earth, there are a few hundred years ago.
Yeah.
So
Because gravity does, strong gravity does the same thing.
in the theory,
Yeah.
time travel is possible.
Yeah. Oh, time travel is only possible forward in time. Like I have a time machine. I get into it, I take my family in it, we sit into it for an hour, and then when we get out of it, it's like an hour later, and we're somewhere else. Yeah, it's called a van. Yeah. Oh, is this the TV show Flash? Yeah. I haven't seen all the seasons, but yes. People have also used it to suggest you can go backwards in time, and I think that's because they really, really want to go backwards in time for like TV reasons. But as far as we know, we can't do that. Well, we can't with our current technology. There is a way to go backwards in time that physicists have come up with. It's a theoretical model. If you get a very massive cylinder, by massive, I mean, much wider than Jupiter, like a lot of mass, and make it infinitely long, and then rotate it. In the same way being near a black hole makes things go faster in time, this massive cylinder, the fact that it's rotating will change how time works around it in its rotation. Not the same, no. I don't even know what to call this. I don't know if it has a special name. And when you say infinitely long, you think, well, that must be impossible. And it turns out that even if you didn't make it infinitely long, you just made it really long. You should still...
French
Only Mr. Cosby.
Jackson State. This guy's blue. It's great.
Yeah. Right?
Yeah.
Pencil is 10 inches. Like, so if the entire world was dried out in a desert, would the sky be yellow then? Or brown? B can also be subjective, I think. I'll say number 2 then.
Because it's small.
I think B, but I'm not too sure. B.
Objective.
D. They basically mean the same thing.
Doesn't on sale mean like on sale for less?
didn't switch your slide. You still didn't switch your slide. What's the force limited to? The thing is, movements and balance are not allowed, but like anything else are
cultures don't believe. Okay, most people, I feel, don't believe is Santa Claus by a certain age, but some religions and cultures don't even, like, just teaching their children other things.
Does Halloween count as well?
Cultures don't.
Well, in
Yeah, Australia doesn't.
I think it was Switzerland, I might be wrong, instead of doing Halloween like in October or whatever, they do something else where they'll go down to start the new year. And it's not like dress up or anything, it's just like a nice way to start the year for them. There's something, I have to check the presentation I did in French class to be sure, but.
like in India where we eat with our hands, but here we don't. Yeah.
Oh, that's a good one.